Okay, so this is going to be our first lecture, obviously, and this is going to be hopefully a really brief overview for you. A lot of these topics, this idea of scientific methods, I'm sure you've had a million times. So I'm going to fly right through this one. And as always, if you have any questions, we can talk about them in class. Started. So I had you guys watch that video from Jizza, from the Wu-Tang Clan, right, last night. So, and there's a quote up there from him that kind of talks about the power of science, and he gets to the reason why I use him so much is that he gets to the idea that science is not something that happens necessarily in labs, in classrooms, in an organized way. Science is something that happens all around us. And he stresses, which I appreciated so much, he stresses that connection to music. And I think we don't always, at least I didn't when I was in high school and even in college, I didn't really see science as something that was all that accessible. You know, I thought you either had a mind for science and you didn't. I didn't realize that just by having minds, we have minds for science. So I've got a quote up there from him, which you can read. And you heard what he said. So also hilarious, right? Wu-Tang Clan, not known for their educational support or moving us forward as 21st century thinkers, but who knows, right? And that's why I appreciate him too, is that he kind of comes out of nowhere and says things a lot better than I could. All right, moving on. So when we talk about science, we don't talk about a discrete body of knowledge, right? Science is not in a book. Science is not, an external thing that we have to memorize. Science is actually just, it's a way of knowing. It's a way of doing. It's a way of answering questions. And I want that to be a fundamental concept, topic. So almost even like our mantra throughout this year is that science is just a way of knowing. It's a way of getting information. We do this all the time. We've been doing this since the day we were born. We will do it up till we breathe our last breath. So science is just about doing. It's about answering questions, bottom line. Now, this is biology. So obviously those questions that we're going to be posing and answering are going to be surrounding the topic of life. So when we talk about life, the study of life, so when we say, remember, scientific study, we're talking about basically what we're saying is we are going to ask questions and seek answers about life. This means life that's present now. We're talking about extinction. We're also talking about our interactions with the non-living things around us. So it's huge. Biology is a very huge discipline, and essentially everything connects to biology. And it's one of the reasons why I have chosen to major in it in college, is because it's one of those things that we can study on the micro level, cells, DNA, atoms, but also on that macro level. Ecosystems, our place in the universe, why we can have life on Earth, but not necessarily other planets. Let's talk about how we go about answering questions, and this is probably the slide with the most information. So how do we go about? Well, there's a million ways basically, but we try to group those ways into discovery science and hypothesis-driven science. So discovery science is basically about describing what you see around you. It is based largely on observations. And you can be very systematic in your observations. So you can look and you can even quantify your observations in a way where you can then analyze them. So we tend to think a lot of times of observational science or discovery science as kind of like the hippie science. Anyone can do it. Just go out there and observe and take notes. But really, if we think about discovery science, we have all of the astronomers use discovery science. Newton, discovery science. As I'll show you in a second, a large part of our social sciences are discovery science. So we owe a lot to discovery science. The second then is going to be a little bit more quantitative in many ways. That's our hypothesis-driven science. This is the one that is a little bit more structured, you would say, and it's more about explaining what you see. Okay, this is what I see, this is what it does and how it works. So you've got your hypothesis, you're an answer to a question, or a tentative answer to a question that you have to be able to test. And once you have your hypothesis, you then can move into the experimentation process. A lot of times when we talk about hypothesis-driven science, we're talking about a controlled experiment where you have a dependent variable, an independent variable, you've got your control factors. And basically what it is, it's testing to see whether those results are as predicted. Was your hypothesis correct? Okay, there's something to that. Was it wrong? Even better. Because then we can go back and refine our work and move forward and try to, again, answer some of those questions. So you're also going to be using your if-thens. If XYZ happens, then XYZ is going to happen. So you have a cause and effect relationship, a causal relationship with those two. So when we talk about discovery science, here we go, monkeys, and you've got your Jane Goodall, and she's watching monkeys, and they're just doing what they do. And here you go, and she records her observations. This is a great example of that discovery science. Now, when we talk about hypothesis-driven science, this is where we talk about, and I'm sure you've heard, because I did when I was in school, this idea of the scientific method, right? There is a list of steps. You do them in order, and that leads you to some answer. Now, science is not this neat. Science is not this orderly. Science is not this structured, right? Science is really messy and it's frustrating, and I think it's good to know the structure of the hypothesis-driven science, but don't be hung up on it, right? So if you don't think in a linear fashion, if you're struggling to connect your hypothesis to your experiments, to your results, that's normal, right? You're still doing science. You're still answering questions. So generally speaking, when we speak of hypothesis-driven science, you have your observation, right? And this one is like, your remote doesn't work. So that's your observation, right? Well, then what happened? So then you come up with the hypothesis that the batteries must be dead. Okay, great. Predict. You have new batteries. It's going to work. Great. You replace them. Perfect. If it works, then you can always repeat this to see if this was the thing, if this was the cause of the remote not working. Or if it doesn't work, you revise your hypothesis and you keep going. But I'm going to warn you, in my experience, science doesn't necessarily work in this pretty line. It's a great kind of idea to have as we conduct our experiments and as we go through answering questions and asking questions. But what I've seen a lot is this is such a very simple example. And in science, the more complicated the example is, the more difficult it is to kind of adhere to this list of steps. So I say that because if you are put off by or if you've struggled with this kind of idea of methods, and if you don't necessarily think linearly, that's okay. Many scientists don't. On the other hand, if you do, that's okay too, because many scientists do think that way, and we need every one of us to kind of pool our strengths and our resources together to, like I said, ultimately answer those questions.